Okay, do you have any other questions on the 3-2 homework that I didn't go over yesterday, maybe?
I'm trying to do the second derivative on 30, but I'm kind of struggling.
You have the first derivative,
What?
right? You have the first derivative.
Yeah. Second derivative.
Okay, and you got this, I think we talked about this yesterday, right?
Yeah, a little bit. I think you told me, like,
You have that, right, as your first derivative? Because that's what your first derivative should be. Yes?
Yes.
Okay, so when you go to find this second derivative, so we're still using the quotient rule. And I'm just gonna set it up, because we're gonna have to actually like multiply this out in a second, okay? Okay, so it would be the G times the derivative of f. So my derivative of f, I can actually do this would be negative 2x minus, and then I'm gonna have f times, now, I don't know what this is yet, so you either have to figure this out or go ahead and write like d of x of that, okay? So if I were you, before you put this in here, I would go ahead and multiply this out together, because you're gonna have to know what this is. Because you don't know any other shortcuts to do like parentheses squared. Okay, so this would be x to the fourth minus x squared plus 1, which is x to the fourth minus 2x squared plus 1. Okay, so then if I do the derivative of this, that'd be 4x to the third minus 4x plus 0. Okay, and then it's all over g of x squared okay, you good so far? Okay, so then we have to multiply on top and then combine like terms, okay? Now, it's gonna be, do you wanna do the long way or the short way?
Will we know the short way?
Well, okay, I don't know. I
Will
don't
the
know.
short way come in handy?
Yeah,
Then let's do it.
okay, alright, so do you see how this has an x squared minus 1, this one has an x squared minus 1?
Yeah.
So like, let's see if we can get this to be x squared minus 1, okay? So if I can't change this part, because even if I take out a negative, that's gonna make this positive, positive. So I can't do anything about this one. Okay, but on this one, if you take out a 4x, you're left with x squared minus 1. No. Does everyone understand how that's x squared minus 1 to the fourth on bottom? Okay. Now, the reason why I would do that is because now they all have one in common, so you can go ahead and cancel one of them out. It makes it easier when you go to multiply. Okay? So if I cancel one of them out, this would be x squared minus 1 times negative 2x minus, I would have my negative x squared minus 1 times 4x, but this one disappears completely, over x squared minus 1 to the third okay, so then when I distribute on top, I would have negative 2x to the third plus 2x plus 4x to the third. Okay, do you know why that's plus 4x to the third?
This is minus sign.
Because this is, if I substitute, that would be minus minus, good. Okay, and then this would become negative 4x, but negative 4x would be positive 4x. Over. So then my second derivative, if I combine like terms, would be 2x to the third plus 6x. Okay, and just because I think I told you this earlier, like you can leave your answer like this, then I'll always go it down to like completely factored if it's possible. You do not have to, I will not take points off. But this would be your completely factored form, but this one is also acceptable.
So what if we like didn't take the thing out?
Okay, then you would have distributed it, combined like terms, and then you would have had to refactor it.
Have to refactor it.
Yeah.
Like how do I do that?
Like when you're, so then you would just, think, first thing you do, did you FOIL this? You got this, so then you have to multiply those two together.
Multiply what to?
Negative 2x, okay. So you had negative 2x to the fifth plus 4x to the third minus 2x. Okay, and then on this one you had plus 4x to the fifth minus 4x to the third minus, so that becomes plus 4x to the third plus 4x, so minus 4x. Is that what you had so far?
Yeah.
Okay. So when you combine like terms, you had 2x to the fifth plus 4x to the third. Yeah. I'm forgetting what I canceled. 2x to the fifth, 4x to the third, minus 6x.
6x.
You know what you have so far?
No, I didn't get 6x. I got 2. I think I just wrote that to a straight negative.
Then if I factor out the 2x, I'm left with x to the fourth plus 2x squared minus 3. And then this would factor into x squared minus 1, x squared plus 3. That makes sense? Like I just did, like on this one, I just did like my multiply, add. Multiply to get negative 3, add to get 2, negative 1 and positive 3.
Sure.
I just,
I don't do that chart.
okay, well, okay, whatever you did, I just factored this to those two things. Okay, and then you would cancel it here. Okay. So then I would have had 2x, x squared plus 3.
Like, how can you tell that you have to do that? Because, like, I had factored it on the bottom, too. Like, I had folded it out on the bottom, so I couldn't tell, like...
I mean, foiled it out, like multiplied it out?
Yeah. It's like, how would I be able to tell that I needed?
I would never like FOIL anything out in the denominator on any of the quotient rules because there's probably going to be something parentheses squared. So then you could check to see if it like, because if you FOIL it out, you're going to have to then go backwards and refactor it. On the top, I don't know like that there's an easy like rule to just remember. It's just like once you, if you do all this work, then you get to here, you always just have to check to see, can I factor something? And then I started here, and then I see, well, can I keep factoring this to see if something will cancel? There's no way of like, I can look at that and be like, oh, I know that factors. I know that doesn't answer your question probably the way you want to answer it. But the bottom, I would never distribute these out from the beginning. I would leave them like that, okay? Because you're just gonna make it more complicated. But the top, you're gonna have to, because you have to get those combined all together. Okay? So I would never mess with the bottom. The only thing I would do with the bottom is if I see something on top that's the same, I can cancel. You alright with that, Hannah? You okay? That problem now?
Yeah,
Okay.
I didn't even pay attention to that.
Okay. Just so now. No, that's fine. I don't want to confuse anyone. Anyone else have any other questions on the homework?
So for 41, could you almost kind of do a similar thing and cancel out x plus 1?
Yep.
So
So then your first derivative should be x over 1 plus x, or x over x plus 1. I don't know what order you have it in.
your first derivative should be what?
X on top,
Um,
and then either x plus 1 or 1 plus x on bottom.
If we didn't do that, we still have to answers at fine.
That's fine, yeah, because on this one you're plugging in the number at the end.
I got x squared plus 2x all over 1 plus x squared.
That's what I got too.
Okay. Which is fine, it's just not fully reduced, because you can take an x out. Now, unlike this one, like, she's like, is it fine if I don't, like, you're putting in a number, so it's not gonna matter.
So is it okay if we do leave it the first one?
That's what I was telling her, because you're putting in 1 at the end, it's not gonna matter,
Okay.
okay?
So-
The x squared?
Down here,
No, x plus 2x. Is that, how'd you get from x plus 2x to?
oh, it was, which one was squared, x squared plus 2x?
Yeah.
I have it backwards. Hang on, what did you
I'm just
have?
trying to figure out how you got from
I think
that.
she had 2x squared plus, I don't even know what you had.
X squared plus 2x. You were right with like the before you put the 2.
But that's not gonna give us
X plus
x plus x. Unless I factored when I shouldn't have.
I guess there you, if you have
It would, if you bring out an x, it would be
Is that what you
x
had?
plus,
Plus
oh,
2.
plus 2. I had the first one without the 2 on the front. I didn't simplify it.
You actually can't simplify anything, because it would be x plus 2. You're right. So you should have x squared plus 2x over 1 plus x squared.
So then,
Which is amazing, I got the same answer at the end.
Yeah, I did it wrong to begin with. I did it the way that I was doing it, and I still got the right answer. Like with the switching the G.
I think it's because when you put in 1, like, it doesn't matter, 1 plus 1 is 2, no matter, like, you know what I mean? So I don't think it mattered on my thing.
so I have 1 plus x squared, and then I go x.
Like 1 plus x squared as in like 1 plus x squared or 1 plus x quantity squared?
Yes.
Which
The
one?
quantity one.
Okay, alright.
And then
Yes.
so and then I have a 2x plus 2 minus x squared plus 2x. And then I factored out a 2 and have x plus 1 all over 1 plus x to the 4th.
So then you could cancel out one of your x plus 1s. You don't have to, you should still get 1/4 in the end, okay?
So when
'Cause you're
I do
putting
this,
in-
the denominator will be cubed, right?
Yes, if they can cancel, yeah.
So then this would
But
mark
it
down
has
to
to-
1.
But you have to make sure, is there 1 in each one?
Yeah.
Yeah. Yes. Okay. Any other questions? Do you wanna start talking about trig now, or do you wanna just stop and start trig tomorrow?
Star Trek tomorrow.
Start trig tomorrow? What day is tomorrow, Thursday? Thursday. Okay, so your homework, will we do Friday, beginning and whatever, 7th period, or you can turn it into me before school, okay? We'll start talking about trig tomorrow, we'll probably finish talking about trig on Friday. Okay? And then next week, we're gonna learn how to do all the trig derivatives.
final. Oh my god, our finals literally next Friday.
Like in a week and a half. That's
Wait,
fine.
oh my goodness.
Yeah. Carly was like, nope, no son, no son.
I can't.
It's our next